Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2020 from the topic of X-rays. This was based on multiple choice correct question. Um Compared to other questions in Paper 2, I will say that this was fairly easy and very less ambiguous. So why am I saying very less ambiguous? That we will figure out very shortly. So let's see what is happening over here. This In the Coolidge tube experiment, there is a cathode and there is an anode. We know that the distance between cathode and anode is d. The potential of anode is v higher than that of cathode. Now the filament current is decreased to half. Potential difference between cathode and anode is doubled, and the distance between the cathode and anode is made half. So based upon these changes, we have to talk about the change in the intensity of characteristic X-rays, continuous X-rays, and the intensity of different X-rays, like all the X-rays, right? So if you just want to recollect the graph between the intensity and the wavelength, so we get this sort of graph, okay? And these are, K alpha, K beta. This is K beta, this is K alpha, and L series will also exist. So basically, we can see that these are characteristic wavelengths, and these are continuous wavelength. This is the cutoff wavelength, lambda cutoff. Okay, so if you want to recollect that, lambda cutoff is nothing but hc upon ev, where ev is the energy of the highest or the fastest moving electron, or the most energetic electron, let me put it like that. Okay, so if you see the changes that is happening over here, we are doubling the potential difference and reducing the filament current to half. That means if you think in terms of power, so power of the all the electron beam that is coming is still constant, 2v into pi by 2. That means power of the electron beam, all the electrons that are coming, that is still constant. So basically, energy of all the X-rays that will be produced is going to remain constant, right? Hence, we can say that energy of all the X-rays are going to remain constant. Now, if you have decreased the value of, if you have increased the value of potential difference, 2V, you have made it double. Hence, we can say that lambda cutoff will become half, because that only depends upon potential difference. So basically, lambda cutoff will become half. So this will be new lambda cutoff. But you should remember that since we are adding up some X-rays, if you see on like these were the X-rays that were not emitted before. So now more X-rays are, like, these wavelengths were not emitted before. So now these wavelengths are emitted, and hence the total energy will be distributed between more wavelengths. Can we say it like that? If only initially the wavelengths that were produced were only from this value to infinity, and now the wavelengths that are produced is from this value to infinity. Hence we can say that the total energy remains constant, but that energy is distributed between more number of X-rays, yeah, more wavelengths. Hence we can say that intensity of earlier X-rays must go down, right? It's pretty sensible. So intensity is going down. Characteristic wavelength, their intensity will not change, okay? Because characteristic wavelength does not depend upon the energy of the incoming electron. It is the energy difference between the two shells. So basically it depends upon the target element. So it is not going to change, and lambda cutoff is going to become half, right? So our answer will be cutoff wavelength will reduce to half. Wavelength of characteristic X-rays will remain the same. So this is correct option. Cutoff wavelength as well as wavelength of the characteristic X-rays remain same. This is wrong, of course. Cutoff wavelength will reduce to half and intensity of all X-rays will decrease. This is also correct. The cutoff wavelength will become 2 times larger and the intensity of all X-rays will decrease. This is wrong. Now, why? So answer will be A and C. Why did I say that this slightly, very minuscule amount of infinitesimally small amount of ambiguity? The reason is that some students thought that it might happen that if we are decreasing the lambda cutoff, then there might be some X-rays, yeah, there might be some characteristic X-rays which were not emitted before, they might start getting emitted. For example, if K beta series, it was not getting emitted before, suppose cutoff lambda was here, let's say this was the lambda cutoff initially. Now if we decrease lambda cutoff, then it might happen that this wavelength starts getting emitted. So in that case, this definitely can be a possibility. But if question says that wavelength of characteristics X-rays will remain the same, so I believe that what they want to ask is that the wavelengths that were getting earlier emitted, if we are talking about that wavelengths, if any new wavelength is getting emitted, then there's no question of talking about being same or not, because that was not something which does not exist before. So we cannot comment up, like it's ridiculous, yeah, it's useless to ask, say whether it remains the same or not, because it is the new thing. So whether something remains the same or not can be only talked about if it existed in the earlier instance. So I believe that we should talk about, we should only consider those characteristic wavelengths which were getting emitted before, and those wavelengths will not get changed. And hence, in my opinion, A and C were the correct answer as reported by IIT Key. Thank you.